Did you know that the chemicals inside an ordinary zinc-carbon battery can be used to produce three different gases: hydrogen, oxygen, and ammonia? In this experiment, we'll perform a practical chemical analysis of a used zinc-carbon cell and generate each of these gases to verify their identities. For this demonstration, we'll use a common zinc-carbon battery. This particular cell has already been used in a wall clock. The outer grayish-silver casing of the battery is made of zinc metal. Zinc is a D-block element that typically loses 2 electrons when forming compounds. Inside the cell, zinc serves as the anode, meaning it undergoes oxidation by releasing electrons. As the battery operates, the zinc gradually dissolves into the electrolyte. That's why the casing of an old battery often appears thin and brittle. Much of the zinc has already reacted during the discharge process. Once the zinc casing is removed, you'll find a layer of paper underneath. Removing this layer reveals a black mixture composed primarily of manganese dioxide, MnO2, carbon powder, and ammonium chloride, NH4Cl. Now let's use these materials to produce and identify three different gases. First, let's generate hydrogen gas. One of the characteristic properties of many metals is that they react with acids to release hydrogen gas. To demonstrate this, we place small pieces of zinc into a test tube and add hydrochloric acid. Almost immediately, bubbles begin to form as hydrogen gas is produced. The gas is then passed through a glass delivery tube into a detergent solution. As it bubbles through the liquid, the detergent traps the gas inside soap bubbles. When these bubbles are exposed to a flame, they produce a distinct pop sound accompanied by a small explosion. This is the classical confirmation test for hydrogen gas, which burns vigorously in the presence of oxygen. We place a small amount of the battery's black powder into a test tube and add hydrogen peroxide. Oxygen gas begins evolving almost instantly. Unlike hydrogen, oxygen itself is not combustible. Instead, it supports combustion. If a glowing wooden splint is introduced into the oxygen, it immediately reignites. This is the classical laboratory test used to confirm the presence of oxygen gas. Finally, we come to the most interesting part of the experiment, the production of ammonia gas. The black paste inside the battery contains ammonium chloride. When it reacts with sodium hydroxide, ammonia gas is released. First, sodium hydroxide pellets are dissolved in distilled water. This dissolution is highly exothermic, producing enough heat that no additional heating is required for the experiment. The sodium hydroxide solution is then added to the black paste, causing ammonia gas to evolve. To verify the gas, a strip of moist pH paper is placed over the mouth of the test tube. Ammonia dissolves readily in water to form an alkaline solution, causing the pH paper to turn green or blue. This color change confirms the presence of ammonia gas. As we've seen, the chemicals inside an ordinary zinc-carbon battery can be used, with the appropriate reagents, to generate three different gases: hydrogen, oxygen, and ammonia. This demonstrates the fascinating chemistry hidden inside a common household battery and provides a practical insight into the chemical composition of a zinc-carbon cell. If you enjoyed this experiment, don't forget to leave a comment, subscribe to the channel, and stay tuned for more practical chemistry demonstrations. Thank you for watching.